This is the 2-bit adder project 1.2. It works quite simply using addition with an A value and B value. It uses 3 gates, a 4070 XOR gate, a 4081 AND gate, and a 4071 OR gate. This is the breadboard prototype of the 2-bit adder. It also uses the same 3 chips, a 4070 XOR gate, a 4081 AND gate, and a 4071 OR gate. Here, instead of slide switches, I have opted to use those rocker switches that I bought. These rocker switches are in order, B1 being this number 1 here, B0 being the number 2, 3 does not have a value. As you can see, it does not connect over the bridge or the valley. 4 is A1 and 5 is A0. These all connect through the wiring into each gate and into the 3 LEDs. The 3 LEDs mark the least significant bit, the middle significant bit, and the most significant bit. Each LED has a binary value and a decimal value. The decimal value is 1, 2, and 4. Each of these LEDs is connected to ground via a 470 ohm resistor. As well, each rocker switch is connected to ground via a 10K ohm resistor. Over here on each one of the gates, they are all connected to power on the pin 14 and connected to ground on pin 7. In these gates, the output pins are faced in the center, and the input pins are both on the outside. The 2-bit adder is comprised up of the full adder and a half adder. The full adder uses all the same chips as the 2-bit adder, but only has 3 inputs, A0, B0, and C in. These are all connected over the valley and to ground with 10K ohm resistors. Over here are the 2 LEDs, which both have their binary values and their decimal values. The decimal values are 1 and 2. These LEDs are connected to ground with 470 ohm resistors. The last circuit in the 2-bit adder design is the half adder. The half adder only has 2 inputs connected with 10K ohm resistors to ground, and only 2 gates. These gates are the 4070 XOR chip and the 4081 AND gate. These connect to the LEDs, which have their binary values and their decimal values of 1 and 2. These are connected to ground with 470 ohm resistors. Here we have A and B, which represent their specific inputs.